So our session's titled this morning, Local Power, National Impact, the Blueprint for Building Resiliency Behind the Meter. Let's start with the first question for the panelists. Why is the shift from centralized generation to localized resilience so critical for the future of power?
I think that resilience and reliability, so really making sure that everyone has access to reliable power that they can afford, is really important. And so there's always going to be a trade-off, right? So yes, you could argue that when you have distributed systems and you have more local power, you're less susceptible to a single event knocking out everybody's power, right? If I have one big power plant, my gas plant goes down, and now if everybody's out in that entire district, that's an issue. So having local power to back that up makes sense. On the other hand, that centralized power, there's a reason we do that in this country, is because that's the most economical and efficient way to deliver affordable power to the masses, right? So there's always going to be a trade-off. When you want to have that, it's more complicated, it's more expensive. Complicated is another word for expensive. So it's more complicated and expensive to basically try to implement all of this. And if you think about things like just operation and maintenance, right? So now if you have to have independent individual operators and maintainers for all of those systems, that's another variable. You have to consider all of these different things that factor into that interplay. But ultimately, the goal absolutely is to make sure for national impact is that we find that right balance so that people have access to reliable, secure power that they can afford.
I think what Erik said is right on. I like his use of the word balance. I would say that there are really two ways of looking at this issue of distributed energy and microgrids. One way of looking at it is that the reason we see a lot of microgrids is because we have consumers, be they hospitals or colleges or whatever, who are very concerned that if there's something that happens to their utility service, they'll be left out in the dark and they can't have that. So a hospital will set up its own microgrid to make sure that if something does happen throughout the city, it can go on its own for a while. That leads to one side of the equation, which is what I would call islanding. And that means that a user of energy will just completely island himself off from the grid and just go completely by himself. You don't see that, really, but the concept is out there. Most of the microgrids and the data centers and everybody else that I talk to say that their preference is to work with the utility, but that because it takes so long for utility to make arrangements to supply them with their power, they really have no other choice but to do things on their own. And that's not their preference, but they're forced to do that. So I think rather than go to an islanded type regime, which I don't think is going to happen, we're going to see more of the behind the meter microgrids coming forward to be not just self-sufficient assets for themselves, but also assets to the grid themselves because they have power that they could offer to the utility at the right price.
At Dragonfly, we have a slightly smaller perspective because most of the systems we're installing, they're behind the meter, but they're for a single RV, a single long-haul truck, a single house, a ranch. But when we speak to those customers, what they're looking for are two things, resilience and ROI. And I think at the end of the day, even as you go to the larger systems, those are the key KPIs they're looking at. The thought on balance is interesting because the folks that I've always thought about looking for behind the meter resilient storage are the ones that are on the edge of the grid with high risk and a lot of consequence if they lose power. I think that bucket, a lot more things are starting to fall into that bucket now just because of the way the economy and the manufacturing industry is changing in the US. AI data centers, more factories, more C&I just in general. And a lot of that is ending up on the edge, and I think that's where these calculations for behind the meter storage are really starting to pop up more and more.
Let's just take that as a segue right into our second question here. What are the benefits to end users for applying a microgrid type system? What does it mean to a commercial industrial group to go get a microgrid and apply it? What are the benefits? Like one of the ones that you named for sure is resiliency, right? Just making sure they have power when they need it. But are there others?
Certainly. I mean, being able to control access to power and to shift that power to when you need it, right? So I'm a storage guy. So I think about storage, and arguably one of the most distinctive things that it does is it shifts energy in time. It's a time transmission asset, right? So we have physical transmission that moves things to the outer edge of the grid, but ultimately what energy storage does is it shifts that electricity and that use in time. So anybody who's working in energy storage, you can call yourself a time traveler if you want. That's okay. But anyway, what I'm getting after here is that it gives them the independence to say, I know as an independent entity when I need electricity. If the electricity is coming from the grid, the access to that is determined ultimately by your generators and your transmission system. So what this really gives you is having these microgrids is the ability to control when you need electricity and how much of it you need in those times particularly, but it's about shifting it in time and being able to control that so that you can best meet your independent needs behind the meter.
It's shifting is a good word, because you're not just shifting the supply of energy for a microgrid. You're also shifting onto the consumer the risk that is associated with doing something like that. If you decide that you're going to separate yourself from the utility, you're taking on a risk of providing for your own electricity. And there's a lot of considerations that go into that. You're going to own assets. You're going to be responsible for operating them. You're going to be responsible for maintaining them. You're going to be responsible for end-of-life management. Those are the kinds of things. And then financing. I mean, can you get the financing for all of that? The answer to those things is that some behind-the-meter customers are willing to take on that risk because they see a lot of value in doing that, and they see reward for their own operations to do that. If they can control what they're doing behind the meter, and that helps with their overall production. If they're making airplanes, for example, if they can cut the cost of energy by better managing it, that helps them with their production of the products that they're making. So that's one of the reasons you're seeing that. You're seeing people willing to take on that kind of risk. Whether it grows, I think it will.
Do you guys see the possibility of another industry sprouting up, an operator that operates, they're not quite a utility, but they operate and have the licensing to dispatch and manage energy for another a group that owns the microgrid?
Absolutely. You're seeing that right now with a lot of companies out there that are doing just that. If an end user wants to form his own microgrid but may not have all the expertise that he needs to do that, he's going to rely on a third-party provider to do that for him. And that third-party provider sometimes will have utility veterans working for them who know how the system works, and so they can make that microgrid work for them and also be compatible with the needs of the utility. That's a growing industry that's out there. And they all need batteries.
So ultimately, I think what you're talking about here is recognizing that the grid for the last decades, hundreds of years, whatever it is, has been a one-directional grid. Power is generated, and it flows to the user. What you're talking about here is having a new way to think about the end user now has bidirectional energy flow. It can go to them, or it can flow back. And the policy, the infrastructure, the markets, all of that stuff is struggling to catch up to that idea a little bit. And I do think that there's possibility, but this is not a small thing. You're talking about the largest machine in the world, the U.S. electric grid. Finding ways to change something like that's been going on for decades, it's going to take a little bit of effort. It's going to take new technology, it's going to take new policy, it's going to take new players, like some of these entities, and a new way to sort of think about electricity as a bidirectional entity and not just a one-directional entity on the grid.
So let's switch gears and talk about the technology itself. It's still an emerging market. There's not a lot of behind-the-meter applications yet. Small factories or a warehouse that's actually implemented a solar plus storage system. Let's talk about, for that bold facilities manager that wants to engage in this microgrid deployment, what do they need to look out for? What are the key technical challenges that they should be considering and looking at before they rush into a microgrid deployment?
Well, they need to look at their requirements. Reliability is one. Resiliency is another one. Security is a very very big concern, especially when we have all these attacks on the grid and all that. But the overarching thing is that once you identify what are the things that you really need, then you got to look at the cost. how much are you willing to bear in order to take advantage of these innovations that are emerging out there in the marketplace?
So our ROI analysis is the very first and foremost thing you got to do. Not quite a technical front, but still, it's super important to making sure it works right.
Yeah, I mean, at a small scale, I can run you guys through what happens exactly when somebody calls in and they want to spec a storage system with Dragonfly Energy. First thing is peak loads. What are you drawing? How often are you drawing it? What does your demand cycle look like? Second is, what's your goal? Some folks are calling in and their goal is to get out there and stay out there longer, which is one of our mottos. In order to do that, you need to think about, well, how are you going to supply energy to those batteries? Depending on your demand cycle, hooking up to shore power occasionally might be enough. But with some of our customers that have higher demand, they want solar. They want the ability to charge off an alternator on that mobile unit. And again, all those things come with cost. So it's first the simple math of electrical energy mass balances and energy balances. After that, you really need to understand the goal of the customer.
There's a lot of promise out there that isn't necessarily backed up with reality. And so one of the things that we try hard to do at the Department of Energy is to validate technology. So there's an entire facility that's called the Grid Storage Launchpad, whose job is to basically validate the performance, particularly of emerging technologies and in specialized use cases. So let's say you've got you're trying to put together a new aluminum smelting plant, and you want to put some kind of storage together that's going to help support that. There's a particular power profile and a use case that you need to meet, and it's not obvious necessarily from the spec sheets on local battery company X that they can do that. So looking for these opportunities and really take advantage of what's coming through your taxpayer dollars to support these things is to validate those technologies and make sure that you can find sort of a source of truth and understanding comprehensively of here's what this asset can do, and now I can really consider whether or not that's going to play into what I actually need.
Let's just talk on the policy front for a second. What policy incentives or regulatory framework are most important to accelerating behind-the-meter adoption?
So I don't have as much policy thought on the grid and interconnection side, but something we are thinking quite a bit about is the lithium cells themselves. In terms of BESS with lithium, the cells that go into those installations are almost as commoditized as the raw lithium that comes out of the ground. And it's because of these large-scale factories, largely in Asia, producing them.
And the volume.
And buying them. And so from a policy front, what I struggle with is, I think we've got good policies in place to encourage American manufacturing and encourage American consumers to purchase goods from, the American industry. But especially in lithium, when you're that commoditized with the cells, I worry and I wonder what policymakers think if the American consumer is going to buy an American good. That's very good. I agree that that's a great end goal. But for those American manufacturers to be competitive in a commoditized market like lithium batteries, they need access to other markets other than just the U.S. And so how do we position American manufacturers that are producing these goods for energy storage that are largely commoditized to compete globally? I think they're competing here domestically now really well, but the scale that is needed to compete globally, we need to think about, I think, a little bit.
If we can arrive at a kind of a regulatory scheme that would enable American companies to streamline their innovation from development all the way up through production and shorten that timeline, that would go a long way to helping American industry be more competitive on the international stage.
What's it take to kind of open up our whole nation as a whole into a more open energy market where local manufacturers can compete in this environment? Specifically, the ability to buy and sell energy. Some states do not allow you to export energy out of your building. So what would it take to just allow that first step to happen?
I think all of this is going to have to basically be looking at the entire ecosystem and trying to identify sort of an assessment of here's the resources that we have. And we have tremendous resources in this country. We have resources that are overbuilt, they're not being used efficiently. So to understand first and foremost what we already have in place, how do we use it the most effectively so that we don't jeopardize the reliability of what we're delivering and the quality of the product. So remember, electricity is not just electricity. It has to run at the very special conditions and frequencies and voltages and so on so that it turns on your cell phone and charges whatever's going on your stuff, that all this beautiful stuff we see at CES. So we need to make sure that we don't jeopardize that. So understanding how do we take best advantage of the tremendous resources, all of the generation that we have, the generation that's coming online, that's planned moving forward, looking at those things, and then understanding what are the needs that are very different in different places. So the reason California does things differently from how Texas does things, their markets are not the same.
I agree with everything Erik just said. I will say that there is a movement out there. It's been going on for decades to bring the Western interconnection together with the Eastern interconnection, and also bring Texas along as well, because ERCOT is its own grid. And the Grid-Wise Alliance is out there trying to do just that with long-distance, high-voltage, direct current transmission.
Let's assume that there's 10 or 12 facilities managers standing here in our audience, and they're getting ready to deploy microgrid for their building. They got a single-use building. It's 100,000 square feet. They've got a diesel genset sitting out back, and they want to displace that diesel genset with a microgrid. Their primary thought is just to replace the diesel. It's a backup system. But there's a lot more to a microgrid than a backup system. What more can a microgrid, deploying a battery energy storage system, what more can it offer that facilities manager? I'll start with you, Erik.
It depends how they have it connected, to be honest. But I would say the number one thing, which is actually super, super hard to quantify, is this concept of resilience. We don't even know how to assign a value to that. So if they're looking for resilience, that's going to be the number one goal of what they're trying to get after there. Anything beyond that is going to come in things like fuel savings and understanding of other economic costs that are assigned with their current state of how they're managing their backup system. So if they're going to look at a microgrid, it's going to have to be a balance of where do they offset some of the costs of that current system with whatever they're going to put into that other place.
Vic, how can we help? What can a battery energy storage system do in a microgrid?
So, I mean, if you're going to replace a diesel generator in one of our applications, after you cover the resilience and ROI portion, the next logical step is integration. So I suspect this diesel set generator is well integrated with the facility. It's very easy for those guys to maintain it, operate it, fire it up in case of an emergency. Now you take that out, put BESS in. You need to make sure what one of the challenges that ultimately comes up that you have to kind of get over together is integrating that new piece of equipment with the facility. Is there additional thermal management or discharge control, electrical control, maybe SCADA you want it to tie into your actual electronics of the facility and these sorts of things. So after we have a clear case for the microgrid, whether it's resilience, ROI, or a combination of both, then we need to chart the path to actually integrating that BESS into the facility, and then after that, it's integrating it with the grid ideally, but first with the facility. And occasionally, and often, that requires a little bit extra engineering, more cost, and work in collaboration with the end customer so that they know how to operate it, maintain it efficiently on the back end, just like they knew how to do the diesel generator.
You know, the other thing to think about is that what a battery, for example, does works on a different time scale than something like a diesel genset. So the time scale that you can get response is different. It's much, much, much faster. So it gives you access to what we call sort of lower end or lower voltage opportunity spaces where you can get into some of these things where you're just doing some peak shaving, where you're doing some demand charge reductions, where you're able to get access and use that stored energy, and it is stored energy, not generated energy. That stored energy, if you can use that a little bit more effectively on a faster time frame, you get benefits out of that too.
In a way, you're kind of seeing that already. I mean, I've been to cell towers where I see these solar panels and all that, and I see batteries at the foot of the things in the little compartment there, and then and they work fine. They work off the grid, but if there's sunshine, they turn on the solar panels and they work with the batteries. And then off to the side, I'll see this diesel genset that's been sitting there for maybe 5-10 years, hardly ever used because there's never really been an emergency for that. So I think you can see situations, especially in telecom, where you're seeing batteries already work very well.
what paints success in your mind? Behind the meter type applications, distributed resources. If you were going to say 5 to 10 years from now, your vision, you're seeing it in the field working, what counts as success for you, John?
Economic value. What is the most economic value out there for what I'm seeing out there? Why is it in my interest to do A rather than B? If I see A being more economically advantageous for me, I'm going with A.
Hopefully in 5 to 10 years, I would love to see a technology that's safe and cost effective for the residential utilities. Like I fully expect in 5 to 10 years that we can offer these utilities, particularly the ones in wildfire-prone regions, a safe and economical energy storage system to allow mandated home storage in some of these regions and maybe spur some of this adoption and distribution of storage.
So I'll come back to the standard line that I've sort of hit on here throughout, and that is that the future of our energy ecosystem in this country is going to be defined by reliable access to electricity, the affordability of that electricity, and our ability to generate and distribute that electricity. So for me, success will basically be, in 5 to 10 years, is recognizing that everyone in this country can trust and count on having affordable, secure access to that electricity.
Availability of the technology to a broad landscape. That'd be great.
It's bigger than the technology. It's got to be the policy. It's got to be the mindset. It's got to be the social acceptance. It's all of that.